Okay, so we're back to here and we're going to continue with this. And the point that I want to make in this video is main point. Not all functions have nice antiderivatives. Every elementary function has a nice derivative. Not every elementary function has a nice antiderivative. Okay, so how are we going to look at that? Well, instead of looking at f of x equals cosine x, let's look at something that kind of looks deceptively easy. We're going to say f of x is equal to x squared divided by 9 minus 1 to the 1/2 power. So that's going to be the square root. So basically that's the square root of x squared divided by 9 minus 1. And you go, that doesn't look all that hard. So we're going to take a, we're going to take a2 and we're going to square it. Then what we're going to do is we're going to divide it by 9. Then we're going to subtract 1 from that result. And then we're going to take that result and we're going to take the square root of it. And it says, oh, that's not a value. Okay. So it isn't a value. That's fine, because if you figure that out, we can't have negative square roots. So the lowest value that can have is 9. So we have to start at 9. And then we have to copy that and we have to paste it down into all of our cells. And we come back up, and that's all we should have had to have done. And so then what we find is we have that the blue is this function, square root of x squared divided by 9 minus 1. And the orange is the area under the curve. And we can sort of look more finely at that. By changing our dx, we can sort of zoom in. And so basically, if I plug in x equals 9, actually I can just do 3. I can start it at 3. There we go. That's what I want to see. So when I plug in 3, I get 3 squared is 9, divided by 9 is 1, minus 1 is 0. Take the square root of that, I get 0. And so then my blue goes up like that. And then the area under the blue is the orange, and it goes up like that. So this roughly has 3 to 4 is a distance of 1. The average value is about 0.4, and so the integral of 4 is a little bit more than 0.4. So area under the blue equals the y value of the orange. And I can sort of change that. I can change my dx however I want to change it. Okay. So I say, well, then all I need to do is I just need to find the function that the orange represents. So the derivative of the function that generates the orange line gives me the blue line. So all I got to do is I got to find the antiderivative of x squared divided by 9 minus 1 to the 0.5. And I work and I work and I work, and I start to go, this is harder than I thought. I'm not able to really find a function that does that. And so then I'm gonna sort of preview something that I'm gonna get to in another lecture. I finally say, okay, fine. I'm going to I'm going to go to Google and I'm going to figure out that there's these things called online integral calculators, and wolfram.com is just amazing. So I'm going to go to wolfram.com and I'm going to plug in x squared divided by 9 minus 1 to the 0.5, and I'm going to tell it to compute it with Mathematica, and there it writes out the integral exactly like I want it written out. That's exactly how I want it. But then here it gives me my answer. My answer is 0.33x x squared minus 9 to the 0.5. Okay, that's fine. But then it's got this 2f1 negative 0.5, 0.5, 1.5, 0.1. What is this? And I'm not sure what this is. And I look down here and it's this hypergeometric function. And so then I go, oh, what's the hypergeometric function? So then I click on the hypergeometric function, and then it gives me all this stuff in here. And this is really sort of beyond what we're getting into in a Calculus 1 class. Okay, so the point that I want to make, to reiterate my point, is that not all functions have nice antiderivatives. So the antiderivative of this function is not nice. Somebody has computed it out, but it's not nice. And so part of what we're going to be doing in later videos is numerical integration. And numerical integration starts with the idea of Riemann sums, and this spreadsheet here gets across that idea of Riemann sums and how to do numerical integration when you don't know what the antiderivative is by pencil and paper methods.